In logic, a conditional statement is one that can be written in the form if something, then something else. Using symbols, we could say if P, so I can make P the statement, I win the lottery, then Q, and Q is the statement, I will quit my job. And there's even a symbol for it, P, arrow, Q. So this is called conditional statement. And it's a little different. It means, just like with or, meant something a little different in logic, this type of logic, than it did in just regular like English language. Same thing here, this if then. Well, first of all, if you just have a statement, if I win the lottery, then I will quit my job, that full statement could be true or false. So just because it's written down doesn't mean that it's true. So they're not telling you that this is a fact. So if somebody comes up to you, if I come up to you and tell you this statement, if I win the lottery, then I will quit my job, you don't know if I'm telling the truth or if I'm lying. So it depends. In order for me to, if you think I'm lying, one way you could prove I'm lying is, the only way really that you could prove that I'm lying is if one day you read in the newspaper that I won the lottery. So if P was true, if I actually do win the lottery, but then you find the next day there I am, so if it's not true that I quit my job. If that happens, if I do win the lottery and I don't quit my job, then you would say that I was lying about this entire statement, that it's not true that if I win the lottery I quit my job, because I did win the lottery and I didn't quit my job. So if this happens, then we know that the person was lying when they said, if I win the lottery, I will quit my job. On the other hand, let's say any other combination of things happens. For instance, I do win the lottery, and I do quit my job. So we can't say that the person's lying. We can't accuse them of lying. And in that case, we say that what they said was true. But then some funny things happen, like, what if I don't win the lottery and I don't quit my job? You would not say that I was a liar. You might even say it supports what I said up here. So false, if in this case where both P and Q are false, I wasn't lying to you. You can't accuse me of lying. I just said that if I win the lottery, then I will quit my job. I never said what would happen if I don't win the lottery, that I won't quit my job. So that's true. And now one of the more confusing parts of this is this situation. So in this situation, you find out, no, I did not win the lottery. And then you come into school the next day and you learn that I did quit my job. And you might say, okay, you lied to me. You said you'd only quit your job if you won the lottery. But no, I didn't say that. I said, if I win the lottery, I will quit my job. There might be other reasons that I quit my job. Maybe I got a different job. So even though this is kind of weird, both of these ones are kind of weird, but you definitely can't say they lied. If they don't win the lottery, no matter what they do, you can't accuse them of lying. So the only situation where a statement like this, an if-then statement like this, is false, is if the is if the P, the first thing, by the way, this thing is sometimes called the hypothesis, and the thing after the then is called the conclusion, just to give some terminology there. So if the hypothesis is true but the conclusion is false, then the conditional statement is false. And that's why the truth table for conditional, let's get the 4 standard rows. The only situation where it's false is situation number 2, and all other combinations of true, false, it will be true. Now, one of the confusing things about these if-then statements is that in the English language, when I say, if I win the lottery, then I will quit my job tomorrow, it's kind of like saying that one thing causes the other. But in this kind of logic, it doesn't matter if if one thing's actually causing the other one to happen. Like here it says, if the Yankees win tomorrow, then it will rain in Chicago tomorrow. Now, there's no way that the Yankees winning or losing somehow causes the rain in Chicago to happen. Nonetheless, if it turns out that the Yankees don't win tomorrow, and it does rain in Chicago tomorrow, then in that situation, because it's not the only bad case where P is true and Q is false, this would be a true statement in this case. Again, we're not saying that the Yankees winning causes it to rain, and the fact that the Yankees didn't win and it did rain meant that there was any relationship like one causing the other. So it is kind of strange in that way. It also lets us say nonsensical things like if 1 + 1 = 3, then Mr. Rubenstein is the Pope, because this is false and because this is false. On the truth table, if P and Q are both false, if P then Q becomes true. So it's a little bit weird, but that's the way the conditional works. This here is the truth table for it. And you should know that in the situation where something is actually causing something else, like the if I win the lottery, then I will quit my job, it's still, this whole process still kind of works in like the real world also, where if it's always going to happen, then you're going to have P. P is, if it's really true, then anytime P is true, Q will be true also, and you'll never have this strange true implies false case. Now, there's also another situation, another type of relationship or logical relationship here, which is something called the biconditional. Biconditional is an expression like this: Paula will go to the party if and only if Quincy goes to the party. And we use this notation. There's a couple of ways we could say that. There's this funny one with the if with 2 F's, but most commonly they use the symbol with the 2 arrows, or the arrow with the arrowhead on both sides. So someone says this: Paula will go to the party if and only if Quincy goes to the party. And we don't know if they're telling the truth or not. It's just a statement. It might be true, it might be false. And I want to see what sort of P's and Q combination causes this to be false versus causing it to be true. So what would have to happen for the person who says this to be lying? Well, for one thing, if P was false, if Paula didn't go, but Quincy did go, that would mean the person was lying, because they're saying that Paula will go if and only if Quincy goes. So if Quincy goes but Paula doesn't, this thing would be a lie. On the other hand, if Paula goes but if Quincy doesn't go, but Paula does go, this would also be a lie, because it's saying Paula will go if and only if. So if Quincy goes, Paula has to go, because it's saying she will go if and only if he goes. So because of this, however, so those things would make this person, if either of these situations happen, this person would be lying. But if you had the situation where they both went, you wouldn't call this person a liar. It doesn't contradict what they said. And even if you had the situation where neither of them went, it wouldn't contradict this statement. And that is why the truth table, P, Q, P, if and only if Q. Here's the standard 4-row truth table. If they both go to the party, if both things are true, it's true. But even if both things are false, it's true. But if one's true and the other one's false, then it's false. So another way of saying that is, if the two things match, the P and Q, P, if and only if Q would be true. If they're both false, P, if and only if Q would be true. But if one is true and one is false, then it is false. And that's the truth table for the biconditional. And here's a question that they could ask, something like this. They want to know, is P implies, or if P then Q, is that true or false? Well, in this case, they're telling us that not P is true, so P is false. And they're telling us that Q is true. And based on the truth table, anytime the thing on the left is true, this whole thing is true. The only time the conditional would be false is if the thing on the left was true, but the thing on the right was false. We can also see in this situation, given not P and not Q, so P is actually, not P is true, so not P is false. And not Q is true, so Q is false. And according to the truth table, false, if and only false, is true because the two things match. So those things are a little bit confusing, but what we've seen today is how conditionals and biconditionals work. Here are those truth tables. But this is definitely a little bit strange to say, if 1 + 1 = 3, then I'm the Pope, and say that's a true statement does seem kind of a weird thing. Also true to say, if 1 + 1 = 3, then I'm not the Pope. Both of those things would be true, because both of those would be on these two lines of the truth table for the conditional. So a little bit strange, the conditional and the way that works when there's like a false thing, when the hypothesis, the P, when that's false, any statement that you make like that will be a true statement. If 1 + 1 = 3, then I have $1 billion. That is a true statement in this kind of logic.